So our final supplemental lesson will be lesson 3.3D, which is where we're going to take one step further into the multiplication of fractions. We're going to look at the idea of cross-reducing. Personally, I like to cross-reduce when I have multiplication of fractions, simply because I like dealing with smaller numbers. Instead of having to get to the end, I have larger numbers. Then I have to figure out how far down I can simplify. So cross-reducing is not one of those things that is required, but it is something that you do need to know, and hopefully you'll figure out as we go along throughout the year, and you move forward in junior high and high school, you end up dealing with bigger numbers. That cross-reducing is going to save you a whole lot of time if you can simply follow those steps. So we want to be able to look at what we're asked to do today. And our goal or objective is to be able to say that I can cross-reduce my fraction successfully before I multiply. Now, once I cross-reduce, then I go back to my original questions that we did in our previous lesson. Can I multiply? Yes. What do? I multiply across, and then I see if I can simplify and or convert. If I can, then I'm good. Always keep it in mind that when I have these type of problems, we will start out once again with just fractions, but then we also have to look at the idea of having whole numbers and mixed numbers, which we can't have. They can only be in fraction form. So as we get started, then we want to be able to look at the idea of cross-reducing and what that means. So cross-reducing means exactly what it says. We're going to go across diagonally. Sometimes we'll be able to go straight up and down because they'll give us a fraction that can be reduced before I do any math. But the idea is, most of the time, they're going to give us already reduced fractions that we're going to multiply. But I want to reduce. I want to divide a top and bottom number by the same number, right? So we have our divisibility rules. Once again, I believe that's page 9 in your packet. Or on Canvas, I put a clearer image because some of the copies that I handed out, I was told, wasn't very clear. But we're going to look at the 2, 3, 5, 9, and 10 and see if we can reduce any of those diagonal pairings or even the fractions that we're given. So this is the way we start. We start with one set diagonal. You can start with the 3 and 9. I'm going to start with the 2 and 4. And I'm going to ask, can 2 and 4 be reduced? Well, when I think about my divisibility rules, I notice that I do have my rules of 2, and we know if it's even, 0, 2, 4, 6, or 8, that 2 will go into it. So yes, I can reduce both of those. I can divide that top 2 and that bottom 4 both by 2. So I'm going to show my work by doing this. Now, if the problems are too small for you to show your work, then just simply rewrite them. I know it takes an extra second and a half of your life to rewrite a math problem, but I promise it's worth it so you can show your work and get your credit, but also so you eliminate some of your mistakes. And then I'm going to do each of those divisibility rules. So I'm going to say that 2 will go into 2 how many times? So I cross that out, and when I divide it, then I put their answer. So 2 divided by 2 is 1. And 2 will go into 4 how many times? Well, 4 divided by 2 is 2. That's as low as those will go. So then I want to look at the 3 and 9. Is there anything that I can do with the 3 and 9? Well, the divisibility rule of 3 is that if 3 will go into the number or the sum of the numbers. If they're one-digit numbers, we know 3 will go into itself. Hopefully we know that 3 will go into 9, right? So I don't have to add and see if 3 will go into it. I just know 3 will. So I'm going to reduce. I'm going to divide the top number and the bottom number both by 3. And when I do that, then once again, I'm going to divide and ask how many times the 3 will go into it, and then put the answer. So 3 will go into 3 how many times? Once. And 3 will go into 9 3 times. Now I'm left with nothing else that can be reduced. I'm left with a multiplication of fractions problem. Can I multiply fractions? Yes. What do I do first? I multiply across. So when I look at my math problem and I'm going to multiply across, once again, I draw those arrows so I know which digits I'm multiplying. I have 1 times 1, which is 1, and 3 times 2, which is 6. Now, what we could do if we don't want to attempt to learn how to cross reduce, we could say, well, 2 times 3 is 6, 9 times 4 is 36. I know that I can reduce, and I can reduce by 2, and then let's see, I can reduce by 3, and we'll end up with 1/6. we're just eliminating those final steps with bigger numbers and doing the smaller numbers inside the math problems. Is this something you have to master in 6th grade in order for me to send you on to 7th? No. Is it something that I want all of you to learn? Absolutely, because it really will make your math life easier. So now we're going to go to problem 2. I have 5 6 times 7 twelfths, and I'm going to look at my diagonal numbers. So I have 5 and 25. 2 won't go into them, 3 won't go into them, 5, they end with a 0 or 5. Well, both of those end with a 5, so I know that 5 will go into both of them. So then I ask, well, 5 will go into 5 how many times? 1 time. 5 will go into 25 how many times? 5 times. Anything else I can cross reduce? I got that 6 and 7 diagonally, but there's nothing that will go into both of those evenly, so I've gone as low as I can. So now I'm left with a multiplication problem. Can I multiply fractions? Yes. Step 1, multiply across. So I'm going to multiply 1 times 7, which is 7, and 6 times 5, which is 30. Now, you can check those divisibility rules just to make sure that you have reduced as far as you can, but 7 is a prime number, and 7 will not go into 30 evenly. Therefore, we know that 7/30 is our answer. Sometimes they'll give us some that we have to look at all of the options when we are reducing. So when I go to cross reducing for question 3, we're going to look at this in a couple different ways. But notice I have 14 and 20, so I'm going to start back with my divisibility of 2 because they're both even. So 2 will go into 14 how many times? Well, that's a 7. And 2 will go into 20 how many times? Well, that'll go in 10 times. All right. What about 4 and 8? Well, 2 will go into 4s. They're both even. So 2 goes into 4 2 times, and 2 goes into 8 4 times. But those are both even. So I need to reduce those by 2 again. So 2 will go into 2 1 time, and 2 will go into 4 2 times. Have I reduced as far as I can? Well, notice that I have a 2 and a 10 because my second fraction started out as something that could have been reduced already. So when I'm still left with some even numbers, I'm going to go ahead and reduce those. So once again, I can work with the smallest numbers that I can possibly get to. So I'm going to reduce both of those by 2. And 2 will go into 10 5 times, where 2 will go into 2 1 time. Now I'm left with a multiplication of fraction problem. So now I can simply multiply across. 1 times 5 is 5, and 7 times 1 is 7. But that's top heavy, isn't it? So I have to convert it. I can't have a top heavy fraction, right? We call that an improper fraction. Has to be changed. So once again, fractions are a division, and the top number, no matter if it's bigger or smaller, always goes inside my division box. So I'm going to divide 5 into 7. And if you don't know, you can pick up your handy dandy calculator, and remember, you start with what's inside your division box and type in 7 divided by 5, and that's going to give you 1 and stuff. So we keep the 1. And that is 1 times 5 is 5, which gives us a remainder of 2. Once again, when I start with a fraction and I end with a fraction, then my remainder is my numerator, and my denominator is my divisor. I'm left with 1 and 2/5 as my final answer. Now, as we look at question 3, maybe you see a little bit of different math here, right? So we still started with the same step and we were reducing by 2. We end up with 2 will go into 14 7 times, and 2 will go into 20 10 times. But then maybe you looked at that and thought, 4 and 8. 4 is a bigger number and it will go into both of those evenly. And you're absolutely correct. So when it comes to cross reducing, if you can see that a larger number will go into the two numbers you're reducing, then you can go ahead and do that. So I can reduce here by 4s. 4 will go into 4 1 time, and 4 will go into 8 2 times. Now that still is going to leave me with a 2 and a 10 in the far right fraction. So I'm still going to reduce those by 2. But notice when I do those same steps, and 2 goes into 10 5 times, and 2 goes into 2 1 time, that when I am left with my multiplying across, I'm left with the exact same thing, right? I'm still left with 7 over 5, which still has to be converted into 1 and 2/5. So cross reducing If you know your multiplication facts and you're able to do that with larger numbers, then your work becomes even easier to do by doing it in bigger chunks. So let's look at question 4. So on question 4, let's see what I can cross reduce, right? So sometimes I want to use as big a chunks as I can. Sometimes I just can't do it at all. But let's start with 18 and 9 this time. So on 18 and 9, I'm going to ask, is there a number that will go into both of them? And that answer is yes. I could divide by 3's, right? Because 3 will go into 9, and then 8 plus 1 is 9, so 3 will go into 18. However, what is the biggest number that will go into both of them? Right? So if 9 will go into both of them, then let's reduce by 9 and not have to reduce it twice and only do it in one step. So 9 will go into 9 once, and 9 will go into 18 two times. So once again, if you only saw that 3 will go into both of them and you reduced it down to 3 and 6, that's fine, but then you'd have to reduce down your 3 and 6 and you'd end up with 1 and 2. How about 6 and 30? Well, they're both even, so I could cross reduce with 2's, but then I'm still going to have to cross reduce because then I'll have to reduce with 3's, to where if I know my multiplication facts, I can see that 6 will go into both of those, right? So let's cross reduce with 6 and only have to do it in one step. So 6 will go into both of them evenly, and so 6 will go into 30 how many times? Well, 30 divided by 6 is 5. And 6 goes into itself. 6 goes into 6 one time. So that leaves me with as low as I can possibly go in my reducing. So now I just have 2/5 times 1 over 1. I multiply across in my multiplication. I get 2 times 1, which is 2, and 5 times 1, which is 5. I could always check my divisibility rules and see if I can reduce any lower, but I can't. 2 and 5 are both prime numbers, and 2 won't go into 5 evenly. So I know 2/5 is my final answer. All right, so this is about making our math easier for us and having to do less steps than all the steps we have been doing. So let's check question 5. I see 7 and 21. I don't have any divisibility rules for 7 and 21. So maybe I just ask myself my math questions. Will 7 go into 21 evenly? And if I don't know, I pick up my handy dandy calculator and I do a quick check. I take 21 divided by 7 and I see it does go in evenly. It goes in 3 times. So I can cross reduce the 7 and 21 each with 7 because 7 will go into 21 3 times. And we know that 7 will go into itself, or 7 divided by 7 is 1. And then 2 and 6. That's back to my divisibility rule of evens, right? So I can reduce by 2's. And so therefore I'm going to divide both of them by 2. And so 2 will go into 2 one time, and 2 will go into 6 3 times. Now what am I left with? I'm left with multiplying across. Or I could say, I've got a 3 and a 3, right? So if I had a 3 and a 3, don't they just go into each other? Yeah. So if I divide each of those by 3, I end up with 1 and 1. So wait a minute. What I'm left with in my final step, when I've reduced as far as I possibly can, I have 1 times 1, which is 1, and 1 times 1, which is 1. Well, what is 1 over 1? It's just 1. So your final answer, you just make it a whole number of 1. All right, so I want you to try number 6. Pause the video, come back, check with me. Make sure you got this before we move into the next one. So hopefully as you were looking at this, you could start with either diagonal, but you see that 12 and 40 are even numbers, and maybe you started with reducing by 2, but then you were going to have to reduce again. So maybe, hopefully, you saw that 4 would go into both of those. So if I did that, I took 12 divided by 4 and 40 divided by 4. Well, then 12 divided by 4 is 3, and 40 divided by 4 is 10. Okay, so is there anything else? Can I cross reduce the 4 and 5? No, 5 is a prime number and 4 won't go into it. However, hopefully you see that 4 and 10 are both even. So if they're both even, I know that 2 will go into both of those. So 2 will go into 4 2 times, and 2 will go into 10 5 times. Then hopefully you said, well, I've reduced as far as I possibly can, so now all I have to do is multiply across. And 3 times 2 is 6, and 5 times 5 is 25. And hopefully you just circled that because that is your final answer. That's as low as you can possibly go, right? So now, if you didn't see that, if you didn't get that, then please come to me and let me help you so I can walk you through and see if you are making any mistakes. All right, so now when we get into the second half, it's a reminder that we cannot use whole numbers, we cannot use mixed numbers when it comes to our multiplication of fractions problems. So that means I have to create them and make them into improper fractions. Reviewing that process then. When I have a mixed number and I need to make it an improper fraction, I start at the bottom and I'm going to go clockwise once again. So starting at the bottom, I always show these arrows if I'm doing it in pencil, if I'm doing it on the computer, so I can keep track of what I'm doing. And my first step is always multiplication. So I'm going to do 9 times the whole number of 2. Once again, if you don't know your multiplication facts, I'm fine with it. You can use your fingers or you can get your handy dandy calculator and type it in, 9 times 2, but you need to know that that's 18. The second step of changing into an improper fraction then is taking whatever you get as your product, your answer to the multiplication problem, and adding the numerator that you have. So 18 plus 4 is going to give you the 22. And then I always keep the same denominator. So it started as 9, it has to stay as 9. Then I'm going to rewrite my problem and have my 3 and my 11. Now, I'm going to ask myself, okay, can I cross reduce? Is there anything that will go into anything else? What about 11 and 22? Well, if you don't know, you could always pick up your handy dandy calculator and check, type in 22 divided by 11 and see if you get a whole number. And you should, because 11 will go into 22 evenly. So I'm going to cross reduce with 11s. 11 will go into 22 2 times. And 11 will go into 11 one time. What about 3 and 9? Yep, I can cross reduce those. 3 will go into 9 evenly. So I'm going to reduce by 3's, top and bottom. I'm going to have 9 divided by 3 and 3 divided by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. Anything else that can be reduced, I'm left with a 2 and a 1 in the top, a 3 and a 1 in the bottom. Ones wouldn't change, so now I'm just going to multiply across. When I do 2 times 1, I get 2, and when I do 3 times 1, I get 3. Pretty easy? I hope so. I'm trying to make it as easy as possible, but it's why we review and I show you step by step how to do them. All right, so now I have 2 mixed numbers and I have to make both of them improper fractions. So once again, I should be rewriting my math problem and showing my steps on how we get there. So I'm going to once again start at the bottom. I have a 4 and I'm going to say, well, I'm going to do 4 times 1, which is going to give me 4. And then I take that product of 4 and I'm going to add the 3 to it. So 4 plus 3 is 7. So I now have a new fraction of 7 over the denominator of 4 that I started out with. Now I have my second one that I have to change because it's also a mixed number. So I'm going to start at the bottom. I'm going to have 14 times 2. Once again, you can pick up your handy dandy calculator and type it in. 14 times 2 is 28. And then I have to add my numerator, 28 plus 6. 28 plus 6, if you need to use your fingers, your toes, or anything else, calculators are always good, then you end up with 34. I keep my denominator of 14, right? Once again, my denominators always stay the same. Now I want to see if there's anything I can cross reduce. Well, I notice that 7 and 14, and I know if I multiply 7 by 2, I get 14. If I don't know that, then I take 14 divided by 7, and I see, and I do get 2. So I'm going to reduce both of those diagonally by 7. 7 will go into 7 one time, excuse me, and 7 will go into 14 two times. Okay, so now what about 4 and 34? Well, 4 won't go into 34 evenly, but they are even numbers, right? So I can reduce them by 2. So if I reduce them by 2, I have 2 going into 4 2 times, and 2 going into 34 17 times. Right? And if you don't know that, then once again, calculator, 34 divided by 2 equals 17. And now I'm multiplying across. I have 1 times 17, which is 17, and 2 times 2, which is 4, and that's a top-heavy improper fraction. I can't do that, can I? Huh. So that means I have to do some division. So now I'm going to take my 17 and divide it by 4. Top number, once again, always goes inside the box. And 4 goes into 17 4 whole times, because 4 times 4 is 16. Notice my remainder is 1, so I'm going to put it as my numerator. My divisor stays my denominator, so I end up with 4 and 1/4 as my final answer. We got it? I hope so. You give this one a shot, come back and check with me, and let's see how you do. So hopefully you started by changing both of these into improper fractions. You start at the bottom, you multiply, and then you add. 5 times 4 is 20, and then you had 20 plus 4 is 24, and then hopefully you kept your denominator of 5. So you end up with 24 over 5. And then for your second one, you started at the 28 and you multiplied going around clockwise. 28 times 1 is 28. And then you add the 7 to it. And so 28 plus 7 would give you a total of 35 for your numerator. Kept your denominator of 28. Then cross reducing. Let's see what will go into both. I have 24 and 28. So if I look at reducing those, I might see that the biggest number that will go into both of them is 4. I could do 2, but then I'd have to do 2 again. Or if I use 4, I can do it once. Either way is right, as long as you get to the right answer. So let's look at 4 going into 24 and 4 going into 28. I know that 24 divided by 4 is 6, and I know that 28 divided by 4 is 7, and if I don't know that, then I have my calculator. But then you hopefully notice the 35 and 5, and you reduce both of those by 5s, because the divisibility rule says if they end with 0 or 5, that 5 will go into them. And so you did 5 divided by 5, which is 1, and 35 divided by 5, which is 7. But then did you notice that you don't have to multiply across yet? Notice in the top and bottom you have 7s. So if I do, then I can go ahead and reduce those and change them both to 1. And once I do that, then I have the easiest math of all, because I have 6 times 1, which is 6, and 1 times 1, which is 1. But did you leave your answer in that form? Because that's still an improper fraction, right? So hopefully you just remember that any number over 1 is just simply itself. So your final answer should be a 6. Did you get there? Do you have questions? Please